Hi everyone. Happy Friday. Hope you had a great week. We're going to wrap up our week here with Algebra 2 Easy talking about reference angles. Now, a reference angle is the positive acute angle formed by the terminal side of theta and the x-axis. A reference angle is often denoted as theta prime. Now, acute, always an acute angle. That means it is going to be less than 90 degrees. What it's talking about is when you sketch an angle. So for instance, there's my initial side. Let's say I wanted to sketch a 30-degree angle. There's my terminal side. The reference angle is the distance formed from the terminal side back to the x-axis. So then we just need to calculate how many degrees or how many radian measures that is. For instance, this would be 30 degrees. Everything in quadrant 1 has a reference angle that is the same as the original angle. So for instance, this angle is 45 degrees. From the terminal side back to the x-axis is also 45 degrees. That is a reference angle. And knowing how to use your reference angles and knowing what the reference angle is can help us solve a lot of trig problems. Let's try 330 degrees. Start by sketching the initial side of your angle. So we have 0. We need to sketch 330. Well, now we know that this is 270 degrees down here. And this is also 360 degrees. So 330 is going to be in quadrant 4. Don't forget to draw your directional curve. The angle moves counterclockwise. Now the reference angle, remember, this is your initial side and this is your terminal side. The reference angle travels from the terminal side to the x-axis. And that represents theta prime. Now you might be asking yourself, why not to the y-axis? Well, that's simply just not how you find a reference angle. The reference angle's definition, it is the angle formed by the terminal side and the x-axis. So you might also be asking yourself, why not go to this side? Remember the first two things we said about reference angles. 1, it's a positive angle, and 2, it's acute, which means it's less than 90. If I travel towards the left side of the x-axis, I'm going to have an angle that is larger than 90. So we always go to the closest side of the x-axis. Let's think about this. This angle represents 330 degrees. How far away is it from 360? It is 30 degrees away. So we would say theta prime is 30 degrees. Let's try another one. 210 degrees. Let's think about our quadrantals. We have 0, 90, 180, 270, and then back to 360. 210 is going to be somewhere over here in quadrant 3. We could kind of just think about, all right, well, 210, 180, how far away are they? And they're either going to be 30 degrees away, 45 degrees, or 60 degrees. So we're going to sketch our angle. And don't forget to draw your directional curve. So we have 210 degrees. Now we're going to sketch our reference angle, which is from the terminal side of the angle back to the x-axis. So there's my curve for theta prime. Now we're just going to figure out what is the distance between 210 and 180. And like I said, either it's going to be 30, 45, or 60. All reference angles are one of those three numbers. This is 30 degrees. The same as what we had above, showing that different angles can have the exact same reference angle. Let's try a couple more. Negative 30 degrees. Okay, so don't forget, sketch your initial side. And now we need to sketch the terminal side. Negative angles, just as a reminder, move clockwise. So I'm going to move clockwise 30 degrees. Draw your directional curve. Now again, the reference angle is from the terminal side back to the x-axis. And I could label my angle here as negative 30 degrees. That'd probably be helpful. So what is the reference angle here? Is it negative 30 or is it 30? It is 30 degrees. Remember, the reference angle is always a positive number. So regardless if your original angle is positive or negative, your reference angle will always be positive. Let's try one with a radian measure. 5 pi over 4. Let's sketch our angle. There's my initial side. 5 pi over 4, if you remember from our unit circle, is going to be in quadrant 3. Now, since we are moving clockwise, this is now quadrant 1. This is now quadrant 2. And this represents quadrant 3. So negative 5 pi over 4 is going to be located here in quadrant 3. So I'm going to sketch my angle. Draw my directional curve. And I'm going to label this as negative 5 pi over 4. As a frame of reference, I'm going to label this as negative pi. This would be negative pi over 2. All right, now for our reference angle, from the terminal side back to the x-axis, we have theta prime. Our denominator is 4, which means my reference angle has to be pi over 4. The reference angle shares that connection with any other angle with a 45-degree reference angle. I have 2 more here for you to practice, 2 pi over 3 and pi over 6. Feel free to pause the video and give it a shot, or just do a little mental math and see if you're right. Here are the answers. Theta prime. Okay, we're going to highlight that. Go back and fix this. Here's a couple practice problems. Feel free to pause the video and give it a go. And here are the answers to those problems. Theta prime is pi over 4. No, it's not. Jesus, Pete. Here's those answers. For A, theta prime is pi over 3, and for B, theta prime is pi over 6. And as you can see, 2 pi over 3, pi over 3, pi over 6, pi over 6. I hope you learned a little something from this video today, and I hope you have a great weekend.